All right. Well, looks like we hit a critical mass here, so we'll go ahead and get started. Hello again, everyone, and thank you for tuning in to PAVE's virtual panel today. My name is Greg Rogers, and I'm the founder of Aries Public Policy and a PAVE advisor. I've had the privilege of being involved in PAVE since the very beginning, and I'm very excited to be moderating today's fantastic panel. So the title of this panel is Open Roads Ahead, Using Big Data to Predict Rural AV Performance. And I was telling our panelists beforehand, on a personal note, the topic of this panel is very near and dear to my heart, traffic safety in rural areas. I grew up in a farming community in the Central Valley of California. My grandpa was an orange packer. My grandma worked in an olive canning plant. My dad works in a cheese plant. And some of my earliest memories involve sitting in the back seat, looking out the window, and being mesmerized by the perfectly spaced farm rows zooming by. You can see the horizontal lines, you can see the diagonal lines. I see a lot of nods there because it's just this incredible feeling you have, but it's also part of that feeling of the wide open road in rural areas. And so what I'm really stoked about for this discussion is we're going to dig deep into a really unique joint effort between DriveOhio, TRC, and Youngstown State University, or YSU. And the thing that's interesting about this is that to date, a lot of AV testing and development has taken place in either urban and suburban areas for light duty vehicles, and that's robotaxis and local delivery AVs, on long stretches of the highways, mostly autonomous trucks, and in some industrial settings like mining and some agriculture. But rural areas have not seen quite as much AV testing, mapping, and really deployment for the unique use cases that we're going to see and the unique challenges we might see for localization and other aspects of operating AVs in rural areas. Of course, we're going to start seeing more AV operations in rural areas over the coming years as commercial deployments expand and companies prove out different business models. But this team is really at the frontier of exploring how connected and automated vehicles can improve safety for drivers, passengers, and other travelers in rural settings. Um, with that, I'd like to introduce our panelists. First of all, we have Andrew Wallace of DriveOhio. We have Dr. Jay Kerns of YSU, and we have Dr. Punit Tulpule. Did I pronounce it? Yeah, excellent, excellent. Dr. Punit Tulpule of TRC. And they are joined by YSU graduate students Christoffer Splain, Vince Hepola, Christopher Bluhm, Felix Kina, and Emmanuel Asamanyuah, and undergraduate students Tyler Wood, Anthony Micco, and Nick Winsen. Thank you for joining, everyone, and sorry if I butchered anyone's last name. So Andrew, and I was telling the group earlier, so we're going to run this as if we're at a Transportation Research Board annual meeting reception. We are all talking and nerding out about this subject. So I've told the panelists you can all jump in, contribute your thoughts, help to provide your insights into this topic. So hopefully we will all walk out of this a little bit smarter and a lot more inspired about rural AV applications. So Andrew, I'm going to turn it over to you. Can you give us an overview of this project, who was involved, and what the project goals were?
Absolutely. So I'm with DriveOhio, which is part of the Ohio Department of Transportation. And we were awarded a 4-year grant from the U.S. Department of Transportation. And that was back in 2019. And that was to demonstrate how connected and automated trucks and passenger vehicles could improve the safety for drivers, passengers, and other travelers. So we broke the project down into a few work streams that were focused on either a particular technology demonstration, platooning trucks or automated passenger vehicles, a study about rural mobility challenged communities and their relation to AV, how they might be able to use it and those kind of things. We had a track for community outreach and engagement, and finally data processing and analysis. We had a lot of folks participating in this huge 4-year effort. So we had people from Transportation Research Center, which has an excellent proving ground facility, people and resources for testing and validating just about anything automotive, including automation and other emerging technologies. We had Bosch, who was the provider of the platooning system for the platooning trucks. We had Autonomous Stuff, who upfit the passenger vehicles. We had CDM Smith, who was doing some program management and engineering support. Several university teams. We had Ohio University, the University of Cincinnati, the University of California, Los Angeles, and Youngstown State University. And we also had Ease Logistics, who is the shipping provider that utilized the platooning trucks in their operations. So digging into how we arrived with true big data, between the two demonstration work teams, we had two platooning trucks. We called them Tom and Jerry. They chased each other. And they were used to deliver commercial goods. They went over 23,000 miles, did 107 shipments, and resulted in about 3.4 gigabytes of collected data. On the passenger side, we had two Ford Transits, which we called Orville and Wilbur, along with a Chrysler Pacifica, and those were all running the Apollo open source AV software. We additionally collected some data with a Ford Fusion that was running AutoWare, and collectively the passenger vehicles traveled over 45,000 miles and collected about 59.3 terabytes of data. And that translated to about 363 million rows of individually indexed metrics. This team was under the data umbrella, and they were focused on understanding the collected data and how we might be able to categorize and eventually predict the challenges that the AVs face in the rural environments. So during the demonstrations, we collected data around localization, so where the vehicle believes it is, object identification, what the vehicle believes it sees, planning, where the vehicle's trying to go, motion control, how the vehicle moves about, and disengagements. And then this detailed data, when we combine that with the digital models that we used to help tell the vehicle about all the static elements and rules of the roadway, gives us a wealth of insight into what challenges AVs might meet in the rural settings and how we might be able to anticipate other locations that have similar characteristics that could pose similar challenges. So I hope that was brief. I tried to keep the intro kind of tight.
No, that's excellent. I mean, there's a ton to talk about here, and I'm really excited to hear that there are that you're looking at different form factors. You're looking at you're looking at vans, looking at platooning trucks, and of course you're collecting all this really valuable data about each kind of part of the process of an AV, seeing the world, knowing where it is, and making decisions. Dr. Kerns, I'd like to turn to you, since the key element of this project was the YSU Data Mine Initiative. And so one of the exciting things we saw is that this is creating opportunities for undergraduate and graduate students, like those who are with us, to get exposure in data science. Can you introduce us to the initiative and how you recruited students to this initiative, and maybe the students can provide their experience there afterwards too.
Yeah, thank you. Thanks for having us. Thanks to everybody. So very quickly, the idea was actually born out of Purdue University. They built a data mine. Theirs is 4 or 5 years old. I think 2018, doesn't matter. They've had a data mine for some years. A couple of summers ago, summer of 2022, we had a batch of people that went to YSU and heard about this and brought it back and said, hey, we want to be trying this at YSU. And the way it works is you have a corporate partner, which is a company or organization, and you have like us, YSU. The company provides the data and the problem. And, we got the YSU that provides the students, and they meet in the middle and try to attack this thing, right? So that's kind of how it works. There are lots of multiple corporate partners. DriveOhio was one of them. Let me just point out some of the unique features of DriveOhio, which made it extra awesome. And that is, so one of it is because of the big data, right? They were talking about, I just wrote it down again, 59 terabytes of data. That's a lot of data. And having our students to get experience with that was, awesome. We're jumping on it. Some of the components of that is, a platform to use that. So Amazon Web Services and workspaces, getting our students experience with that is hugely important, because that's what they're going to encounter when they get out of YSU, right? The other really neat part about DriveOhio is, with a lot of corporate partners, they have proprietary and secret information that they need to get a team to work quietly and never divulge to anybody. That is entirely not the case in DriveOhio. If anything, they want to do research for the better of the global community, right? So our students on this team were encouraged not only to solve things, but to share it to the wider world. which made it extra exciting. Okay, so in terms of recruitment, that first year, it was really seat of the pants, right? And then after that, it's more of word of mouth, right? So, and it's getting students recruited. So the way that it worked was we identified the DriveOhio teams in particular. We had a student that was kind of the person in charge, or what we called a TA, a teaching assistant, right? And we have two of those represented today. The first one in the fall semester was Chris Splain, and you can see him up there. He represented the team for the first semester. Most of those students graduated, and we had a kind of new team for the second semester. And the guy who sort of spearheaded that one was Vince Hepola, who's also there, and he was actually instrumental with a lot of recruitment because, like I said, we had a lot of people that were gone from the team for the first semester. I said, "Hey, Vince, do you know anybody that would be good for this team?" And he said, "Yes, this guy and this guy and this person, and here we are." Right. So, and to that extent, I want to turn it over to them to the quickest opportunity I can to get them talking about what they did, what they experienced, and what they learned.
Great. Vince, do you want to start?
I was gonna let Chris start because he had the team first.
All right, Chris.
All right. Well, thanks for having me again. Like everyone else said, I'm like really excited to sort of like catch up on what everyone was working on this past semester because I was one of the students that graduated in December, so I didn't actually get to see everything in fruition, other than the symposium poster and the video that they made. I got to check that out, but yeah, I kind of stumbled upon the data mine. I just got an email from like the chair of the math department, and I saw it, and I was like, you know what? As a non-traditional student, I was still kind of unsure of what I wanted to do with like my degree or like career-wise or like where I was headed. And I saw this as an opportunity, so I jumped on it. I was on it for all remaining 3 semesters that I was in at YSU. The last semester was with DriveOhio. Again, I was a teaching assistant. We had a huge team. It was like 10 or 11 people. So considering I'm someone that already sort of has management experience, it was a huge challenge, especially learning with them and also trying to lead them and sort of tackle this huge pile of data using new tools that we were all learning like on the spot. So it was super rewarding, kind of like the most challenging semester I've ever had, but it was like, no pun intended, I felt like our semester kind of paved the way for like the future semester to actually get some stuff done, because we really didn't get data until like maybe like 10 weeks into the 15-week semester. Getting everyone on board with AWS and like just sort of tackling all those sort of like technical issues, especially considering we don't have all just math or computer science people in the data mine. It's like open to anyone. So a huge challenge was like trying to like see everyone's strengths and weaknesses and try to like bring them up like to par with each other. But yeah, like we started looking at like all the disengagements. We got this huge pile of data that we were trying to sort and kind of like clean up and make usable. And I feel like I'm sort of going on a tangent here, but I'm just trying to like think about the best way to describe like how we tackled our problems. And we couldn't have done it without Andrew and Punit. They were like super helpful in every endeavor that we had. Yeah, but just overall the data mine was like a huge boon to like sort of pushing me in a direction that I would like to go with my career. So that's what I took most out of it. And I'm sure Vince and the rest of the team have a lot more to say specifically about the DriveOhio project. And I'm excited to hear what they sort of accomplished and gain some more insights from them.
Thanks,
yeah,
Chris.
thank you.
And thank you. And before we turn to Vince, I just want to make sure that we understand where this data was coming from that you guys are working with on disengagements and everything else. So this is from the 2 Ford Transit vans and the Chrysler Pacifica that was being driven with the autonomous stuff equipped vehicles, right? And were these vehicles being driven in the automated mode with backup drivers? What types of where was it being operated? Where are these vehicles being operated, and how did you gather that data, I suppose?
Sure. So we first did a lot of off-road testing at the closed course track at TRC to verify and validate everything was all configured correctly. We did operate them on public roads in automated mode. We always had a safety driver behind the wheel and a backup safety driver in the vehicle too. And people were taking notes on what was going on because we really wanted to understand how those vehicles were going to operate in the rural environments.
Excellent. Thank you. That's very helpful. Okay. Vince, would love to hear from your perspective about being a TA on this course or on this project.
Right. So as Chris has said, I wasn't on the team last year. He was a TA, but I was actually on a different data mine team. Another great project. It was more econ based, stats based, and I'm more of a computer science guy. And so this project, since we got the data, there's going to be a lot more coding. So Dr. Kerns asked me to jump ship over the winter break, and I ended up being a lot happier on this project when it came to my own skills and some of the guys that I brought along. Definitely a more suited project for me personally. The previous semester, I didn't work as a TA, but I was helping lead the team, so it was a pretty seamless transition for me when it came to, taking the reins and trying to lead us into a direction that was set up near the end of the previous semester. Yeah, I agree with what Chris said. The data mine has been a huge boon for me personally as well, and I think it has for the other students. It is demanding. It was easily a very demanding semester for me as well. Being a TA and trying to work as a team member as well, trying to get stuff done. But I think every hour was worth it. We did get access to the data pretty quickly because of the work that was done last semester and done over winter break to prepare the new students. And after a couple hiccups, such as only having a very small snippet of the data, we thought that there was like less than 2,000 rows in this table when there's, Andrew, I didn't write down the number, but it was much larger. Once we figured that out, I mean, we just got knee deep in it. Lots of Python scripting, lots of research on how we potentially could model some of this stuff. It was a Wild West when it came to some of the things that we were looking at. We were looking at like GPS signal. We were looking at where each of these disengagements occurred along one of the routes. Mentioned that there are a few vehicles that were driving around. We mostly focused on the Chrysler Pacificas and mostly focused on only one of the routes because of the way that the processing of the data is handled. So those are the ones that we have our most experience with. So.
Excellent. I want to come back to our students in a second and hear about their insights into why they got involved and how it influenced their career interests. But first, I just want to turn to Dr. Tulpule, since you were involved through TRC. Would love to hear about how you got engaged in this project and the value that you see that you saw in participating in it. Of course, TRC being located in Ohio, but having also more test sites across the country. Of course, you have like a broader view on AV testing.
Sure. Yeah. Again, thanks for having us here. Really nice group here. But I think TRC was kind of responsible towards safety of overall deployments of the vehicles, because throughout this project, safety of the vehicles, the drivers, surrounding people, everything was of extreme importance. Like at any point if we thought that something was going to go wrong, we were going to drive in manual mode. So just to collect the data, safety was probably more important than collecting data. And that's why we did quite a lot of testing on the test track as well, because the technology was new to all of us. The drivers had never seen that level of automation as well. So we had to do some driver training. and then actually go on deployment, do some small scale deployments first, then kind of keep on increasing our automation in those deployments. So it was a learning process for us to learn a lot about about the limitations of those vehicles and where they can fail, and what improvements we need to do. We also added some more kind of data collection methods to make it easier for data analysis down the road. But generally speaking, I mean, we had some really interesting things that we heard from the drivers as well. Some of the things that were very specific to rural areas. And there were scenarios that we couldn't see in urban, but those are there in rural. So yeah, it was very exciting. And I think where data comes into picture is that all the things that the drivers told us, those were kind of anecdotal, right? That, on this kind of short turn, the vehicle disengages, let's say, or it doesn't feel quite right, so we have to disengage. Now, what does that mean in data? How do we actually show that what the drivers told us, we can prove it using data? And I think that's where the team kind of started doing it. They started working towards it. They now have the tools set. They learned a lot about, I hope so, that they learned about the AWS process and how that huge data can be concised into something that's meaningful, look at only the disengagements, and then try to understand what happened near those disengagements and start kind of making the dots between the things that the drivers told us and what the data is telling us.
Yeah, that's really interesting because there's a really important human factors consideration here on rural roads, of course, because let's face it, I mean, driving in rural roads, whether you're in Ohio, whether you're in Central Valley, California, can be pretty boring, right? You're passing a lot of the same things, you're going straight. And so driver fatigue is typically something you have to really watch out for during training. And I imagine that was part of your training process with drivers, right? Making sure they're able to remain attentive and have ways of doing that. I'd also be curious if there are any examples of unique situations that your drivers encountered in rural areas where you're able to take that data and maybe inform future development.
Well, one of the things that was kind of important that our drivers noticed was in some areas we lose the accuracy of localization, meaning that there is disconnect from the internet service, and there are certain corrections that we don't receive, and the vehicle is, the accuracy is a little low. And in that case, the vehicle may veer off course. So they did notice that consistently on certain points on the route, there were disengagements, and that happens because of lack of connectivity to internet. Also, there are ravines, there is the tree coverage. All of that can cause the reduced localization accuracy. And that's kind of specific to rural because, it's a curvy road in a big ravine, and that may cause these kind of issues. Now, this is, again, we are speculating that that's what happened. But I hope that we can prove that using data that every time there is loss of localization, there is disengagement. So that's just one example. There is one more kind of weird example where our vehicles were not able to detect traffic lights because there was a tree that grew in front of it. There was a branch that covered it. So, yeah. And we saw some really, some animals like deer. One time we saw a pig walking in the road. So
I believe it. Yeah, I was going to say that chicken crossing the road is not a punchline. It's an everyday part of life where I come from, and so are cows crossing the road. So really unique circumstances there. So I want to turn back to our students. How did you all get involved in this project, and how has this influenced your career interests? Are you interested in going into the autonomous vehicle industry or into transportation? Maybe we can start with just going on my screen here, Chris Bluhm. Did I pronounce that right?
Bluhm, but no worries. It's definitely get that every time, pretty much. Sure. So I actually heard about the data mine a year before I was even at YSU. I was a civil engineer working. Have any plans to go back to school at the time? But then I saw it was have always been very into the field of statistics, tutored it for a long time, and actually I decided I did want to be a teacher. So I'm pursuing my master's in math to be a professor of mathematics. So I had the theory of statistics and everything down pretty solidly, at least at a decent level. But I'd never gotten my hands dirty, and definitely never in 300 million lines of data kind of into statistics. So I had all the theory down, but I saw this, the data mine was looking at, my first round of classes to take in my graduate degree, and decided, well, if I want to do anything with statistics, I need to know how to actually apply the things I know. So that's what kind of drew my interest. And yeah, so that's why I was interested in it. Also, slight overlap with being a civil engineer and transportation. Didn't super get into the nitty gritty of that overlap, but yeah, that's kind of what drew me to it.
That's awesome. That's awesome. And yeah, it's incredible, right? Because there's just unlimited information or data, it feels like, on the internet, but that you can go and you can try and play around with. But it's when you get a concrete project that you can actually work on that allows you to focus and dedicate yourself to learning about how to operate in AWS, or how to operate across all of these different fields and figure out these connections. That's where there's some really incredible power, and that's one of the things I really love about this project. And next step, how about Nicholas Winsen? You help to find you. Oh yeah, 2 seconds.
Yeah, my bad.
There we go.
Sure, I
Yeah.
accidentally tapped out, but I got involved. I know Vince was talking about earlier. He brought some guys in. I was one of few that got brought in for that reason. So I'm still an undergrad, so I just got like Dr. Kern said earlier, I just heard about it through word of mouth, and it was something that really piqued my interest. It's something to actually, again, apply my theory to all the coding I've learned. And it was really cool getting to actually piece things together that I've heard about in class in isolation, getting to use a large scalable database like Dynamo was really cool to work with hands-on with some awesome data. And I think it gave a lot of great experience for me, and just helped me grow as a aspiring software developer. But it definitely opened my eyes to data science. It's really a awesome field, but I love the hand in hand with programming. So it's something I would definitely be open to exploring in the future.
I love that. Emmanuel, how about you? And so I'm going to ask you first of all, how did you get into this, and then I'll broaden this out, and then we'll kind of go as a group. But first of all, Emmanuel, how did you get into this, and how's this affecting your career prospects moving forward?
Okay, so I think back home in Ghana, as an African, after my undergraduate, I was working, and then we used to deal with some huge data set back home. So I wanted to just pursue a master's degree in mathematics, but then looking more like an applied mathematics. And then when I got my when I got into YSU, my supervisor, Dr. Kerns, actually introduced me to the program, which looks more like an applied mathematics. So I was interested, though I had a little idea about programming languages and how it works. So looking at where the world is going, and I wanted to have an experience in that area. It wasn't easy for me because this area is just like a computer science student, and this area wasn't an easy task for me because I just have to start learning programming language from the scratch, and it's kind of difficult. But I'm happy today because I've gained much more experiences that I'm very confident I can build upon, and I'll become a better person in handling big data set. Yeah, so that's it.
I love that, Emmanuel. I completely understand from the difficulty of learning the new language. There was a time where I was really trying to dig into coding, and I learned that I'm definitely a liberal arts person. Let's see. Felix, how about you? How did you get involved in this project, and how is this affecting what you want to do in your career next? Also, I really love hearing everyone's backgrounds and how they came into this. This is just a completely different snapshot into how the AV sector is impacting education and sort of career pathways. Sorry, Felix. I digress. While I'm having trouble coming off mute, oh, we'll give Felix a second. How about let's see, Anthony?
Oh yeah, so like much like Nick mentioned, Nick and Vince both mentioned, I was one of the guys that when Vince asked to come on the project. I'm more of a CS background, so I'm going for my undergrad, and so I've always been a sports fan too. So I kind of want to go into something with the sports field, so like data analytics. And so once I heard about the data mine, I'm like, all right, let me just get my hands wet with data analytics, kind of get a background in that. So once I found out about that, and Vince told me to join the team because there'd be a lot more programming, I really enjoyed it and was glad I got involved. So now I have more of a background in that, and hopefully a pathway to one day being a data scientist and doing sports analytics.
Awesome. Let's see. How about Tyler?
Yeah, so my gracious path was initially I was a math major with a stats minor, then changed to math education, and back to stats, and then still my way into data analytics minor. So
Oh wow, just dancing around all the numbers, right?
yeah, pretty much.
Yeah.
And then at that point in time, my life about a year and a half ago, data analytics minor was the path that would allow me to graduate on time. But being part of the team, like it was intimidating at first because I wasn't much of a coder, and like I don't necessarily know where my place would be. But as time went on, I felt a lot more confident, like working with data and like being able to like interpret it, like how disengagements work and such like that. And I just felt like a lot more confident with like my own capabilities. And now that I have graduated, like it's opened up opportunities where I can look for a job like involving just like math in general, or like pursue actual stuff like involved with the data minor.
Awesome. I love that. I mean, it just shows the scope and the scale of the kinds of jobs around the sector and expertise. Let's see, Felix, last but not least, were you able to get, there we go.
Yeah, sorry for the, I'm
No
also an
worries.
international student. I also joined the fall 2023. I was part of the fall team. And this project has really played a significant role in my life as far as programming is concerned. Thanks to my supervisors and also my team members. I wasn't really good in programming, to be frank. When I started this program, I was finding it very, very difficult in programming languages. It was very difficult for me to really get along with the class because I didn't get that exposure way back in my home country to do programming and play with programming languages. But as I joined the team with the help of my colleagues, they've played a role in my life as far as this project is concerned by helping me with some of the programming languages. When I make mistakes, they try to correct me and show me one or two things to make the programming languages right. And I'm very, very grateful for them, my team and supervisor, and the corporate partners too as well. It's really been a good project, and it has really helped me in my project, in my programming languages. So I really appreciate it.
That's really awesome. Thanks, Felix. I think that's a real testament to this project and the value of this type of collaboration. Thank you all for joining us and for introducing yourself. So I want to turn back a little bit to some more discussion questions that I have, and we had a great question from the audience that I want to cover first, though. Let's see. Mm. So this question is from Cormac McKay, which is that isolation and loneliness is a major mental health concern that could be addressed with better and more desirable and equitable autonomous transport services. And I want to tackle this part of this question because, for a lot of rural areas have a high concentration of folks who are elderly who might soon lose lose the key. We might have to take the keys away soon. There's obviously those constraints, but there's also the challenges of mobility for folks who do not own a car. So there's just tremendous opportunity for AVs to help on isolation and loneliness. But I would love for you all to share your thoughts on how you see from your perspective and your jobs, or from an Ohio perspective, how AVs can help to solve some of those challenges. Anyone can jump in.
I'll go first. That's fine. So I think that like you said, there's a lot of unmet transportation needs in the rural space. There's bigger distances between things, a lot longer drive times, people spending more time in cars. And with a lot of rural spaces, they're economically disadvantaged. And so having the ability to have a car for every person in the household is usually not as feasible. So there are definitely cases where we could see kind of a shared use situation for an AV being able to fill some of those missing gaps. And also thinking about other issues found more in rural environments where, food deserts are a thing, whether they're in urban environments or not. So those are also cases where, potentially like a food delivery type service where you don't need a driver could satisfy some of those other needs too.
I love that, and improving food access is, of course, near and dear to my heart as well. An issue that I worked on over the years, especially as it relates to transportation. And I think that it's really important to think of all these different sort of aspects that we can help to address as we look towards future with AVs. So let's see. Are there any other insights from I want to make sure before we get too far along, because I have a ton of questions for you guys, and I know that we only have so much time left, but are there major insights from your research process or how you've leveraged this data around roadway safety that you want to make sure that we cover before I dive deeper into some wonkier questions with you guys?
Yeah, so there were a few things during the initial process of getting this project started that we were going to target, and that was trying to actually figure out where these problem areas for these vehicles are in the routes that we were given, so that DriveOhio and TRC know where to look and where to add additional testing in these areas. So our results are more preliminary. It kind of points out these areas surrounding Athens, but we call them points of interest. And some of the more key ones are ones that you would expect, like downtown Athens is sort of a problem area, but we're not really too focused on downtown. The point is the rural aspect. And so there were some intuitive, but not immediately, such as, let's say, roundabouts. Roundabouts were a big issue. There is a railroad that cuts through one of the routes. And those railroads and Andrew, you can correct me if I'm wrong, but railroads and roundabouts were considered out of scope for the training of these vehicles. But as we get into the more rural portions of these routes, the satellite issues begin to show up in our data research, at least. So we were trying to draw correlations between this GPS signal loss and disengagements. And we were along that track. We didn't quite get there because we kind of ran out of time for our project, but we do strongly believe that there is one. And so we have some of these maps that we made that basically you plot this point, you plot the locations of these cars driving along the routes, and then you can change the size of the dot by how accurate it knows its location. So you can have a really small dot for basically it knows exactly where it is. GPS lies on the road, and you can have this dot grow based off of basically it has kind of no idea, not a great idea. And then the dot can sometimes completely disappear, which means that it has no idea. It's completely disconnected from the satellite. And so we were seeing these, as you get into the more rural areas, these dots would blow up, and then sometimes they just completely disappear. As you go under a bridge, there's a few bridges that you pass under, and you immediately lose satellite signal, which is like instantly. Those points we were interested in. And then the moment it connects back to satellite, the dots are really big. They start really big and they slowly start to shrink until they become really small and it gets its bearings. And one of the key things that kind of changed the way that we were looking at these dots is the vehicles, when they lose satellite signal, they don't disengage automatically. They keep driving until a certain point where if they don't get connection back and they start to veer a little bit, they still have cameras, they still see the road, they still try to stay on the road. But at some point they lose it and the driver is the one who has to disengage. So they're drawing a conclusion about where these locations are and connecting them to these disengagements was the very next step that we wanted to do. So unfortunately, we don't have numbers, we don't have specific claims, but boy, were we really, really close to being able to actually say something about those. That was probably one of our main findings. Another one was we actually tracked where disengagement started. And so we have this heat map that basically plots the beginning of every disengagement, and you can see these clusters start to form across the maps. And we want to see those split up between these different routes. But just being able to do these things was a huge accomplishment for us, especially having to play with these larger data sets. I think Chris, you had your hand up for a second, but now Andrew has his hand up. So
Yeah,
Andrew,
go ahead, Andrew.
Yeah.
Correct.
We can go over a few minutes, by the way.
I just had a quick addition to what Vince was saying, and yeah, unfortunately, we could talk about our project for 4 or 5 hours. So, trying to keep it as brief as possible. One of the main conclusions we made was, as Vince was saying, we kind of tracked every disengagement. It was a point of interest, and kind of looked at, okay, well, what was going on at this point? We took a kind of screenshot at that point, and what's unfortunate with the data that was processed at the time we did the bulk of our analysis, and why we're so excited for the next team to get started on this is, so we agree, especially in rural environments, a very big cause is the loss of localization, as was shown by our the maps that Vince was talking about. But looking at our summary table where we kind of counted up all the disengagements, the highest one was downtown, occurred most often. And then the underpass where localization was lost under the underpass only appeared 8 times. And that was a product of, for that route where most of our data came from, it was mostly downtown. And while they encountered 20 traffic lights over the course of that run, they only encountered that underpass once per run. So looking at our summary table, which was one of our deliverables, it looks like, oh, well, localization isn't that big of a deal. And it isn't when you're mostly downtown. Signal is going to be really good downtown, so you're not likely to lose it. But that's all I wanted to add, that, and why we're so excited for the next part of this project.
And it brings up an interesting point as well, right? Because you were working with off-the-shelf software, and so you guys weren't able to make changes to the driving software itself, right? And so you get to look at basically the snapshot of a point in time of how that was built, and then try and figure out what some of those issues are. And it's kind of modeling what happens inside of an EV company, which is really interesting as well, just kind of like on a different time scale. Andrew, did you have something that you wanted to contribute?
Yeah, so when we talk about the data that we collected, I think one of the things that we had assumed we would see is that it would just disengage, and we could pretty easily somewhat figure out what we likely thought it would be. But what we found is that the vehicle disengaged a lot less than the person taking control of the vehicle causing it to disengage. And I think we saw that with some of the other projects that we talked about with other states, like Iowa had another rural project they did with ADS vehicles. And they said the same thing, where typically the safety driver would get uncomfortable with the way that the vehicle was performing before the vehicle would actually disengage, which means that we didn't get like a definitive, this line of these things is going to cause it to disengage, as much as this was an undesired behavior that caused a safety driver to take over.
Yeah, and it's an important, really nuanced distinction there. Well, great. I didn't know that we're starting over time, and I mean, I think that we actually could spend a few hours. Maybe at TRB next year, we can all get together and we'll have a beer and chat more about this. I see some enthusiastic nods. There we go. That'll be our TRB reception next year. So two questions to wrap us up. And the first, at PAVE, we work to educate the public about the potential of AVs. And we've seen that sometimes the folks in rural areas aren't always as aware of AVs, how they work, what they could mean for their communities. And for Ohio, how have you been engaging with the public and conducting outreach in some of the rural areas where you've been testing?
Absolutely. Community outreach is paramount, especially when you have these kinds of vehicles out on the street. You don't want people freaking out about it and jumping in front of them to see if they'll stop. So we absolutely reached out to lots and lots of individuals. We ran a series of workshops and thinking sessions with different groups from state safety officials, logistics associations, local partners, leadership from the local cities and local authorities, US DOT, FMCSA, FHWA, FTA, of course, Ohio DOT, and then some other local groups as well. When we started thinking about talking about those with mobility challenges and how the AVs may enhance their life quality or their community at large. We also had a wonderful time working with PAVE on a scholarship essay contest where we engaged some local students. They all wrote essays. We went through them and graded them, and it was very promising to read how the upcoming generation was thinking about AVs and how they might impact their communities for a better future for everyone.
Yeah, I've really loved loved reading the students' essays and the PAVE essay contest. I think it's just a tremendous opportunity. It just shows how many different ways there are to engage with this topic and how it makes you think about the broader world. So for anyone to jump in with on the last question, how do you see the future of CAV development in rural areas, or where do you see this project or its outcomes leading to in 5 to 10 years? So love to hear from a couple of you on what you think there.
I was trying to wait to see if somebody was going to jump in before me. So I'll share a little bit. We are engaging another round with the YSU data mine to further dive into the findings that they've had thus far and start to look at maybe doing some more predictive analysis. So taking a dive into the digital models that we used to inform the vehicles of where they were and what the rules of the road were, and using those as correlated against the areas with the unexpected or undesirable behaviors of those vehicles, and start to extrapolate out across the state and maybe even further where other areas that there may be other issues that we might want to collect more data and either verify that, yes, those disengagements or undesired behaviors do occur there, or maybe they don't occur there, and maybe there's something we need to adjust with the way that we're doing our predictive analysis. And then the hope would be,
Yeah,
Yeah.
what I love there is it's like softening the ground for when, deployment does happen in the area. Sorry. But yeah.
Absolutely. Oh, yeah, no worries. The idea would be to hopefully identify things that we may be able to do from an infrastructure perspective, or that may be able to be done from a software perspective, to address some of these challenges as we look to scale, because 97% of the roadways and land mass in the US is rural. So at some point, in order to reach that critical mass and have adoption across the nation, we have to solve some of these problems.
Absolutely. Absolutely. Anyone else want to close us out with some final thoughts?
Can I jump in
Go
here
ahead.
very
Yeah,
quickly just to
absolutely,
say
Dr. Kerns.
just a couple things. So, and some of these ideas have kind of peaked out in a couple different places. One of the things that I just want to point out is one of the things about these autonomous driving, and related to your question, is these data are a moving target. That is, and normally whenever I'm in a class, I've got a self-contained data set. Here you go. Here's an exercise. Go solve this problem, and then we'll go do the next one. This is completely different. This problem is bigger than any of us even understand. These data are moving. They're moving. The data that the students get access to changes sometimes on a daily basis, right? They're collecting data, and this is a problem they worked on for 9 solid months. And you ask what's going to be 5 years from now, they're still going to be working on this in some capacity, right? This problem is bigger than any of that, right? So I just wanted to add in those quick 2 cents about that.
No, that's a fantastic point. Yeah, go ahead, Vincent.
Yeah, and Andrew already mentioned it, but we are going to continue this project in the fall. I will be TAing this team again come fall and spring of next year. So given that a lot of the groundwork has been set as for our team, specifically at YSU, we have some Python tools built. We have access to data. We know how to pull it. We know how to clean it. We know how to wrangle it, and that we can really hit the ground running to do this kind of predictive stuff that we want to attempt, some more ML stats, and I want to start now, but we got a new fresh group coming in fall, so the idea of the data mine is that anyone can join, and so we will have a little bit of a period of training and trying to get everybody up to date, but it's so exciting to see. We were under kind of a time crunch this past semester, but we have everything set, ready to go. I'm super excited to see what we're going to be able to do starting in the fall.
I love that. I love the enthusiasm. Congrats to you guys on the completion of these past 4 years of the project. Really excited to see where this goes, and thanks to all of you for joining us for this awesome panel. It's really excited to participate and to hear from all of you. Thank you to everyone for tuning in. We will be posting the recording for your friends, for you to share with your friends and family, neighbors and strangers, whoever you want to. We'll be sharing that afterwards. We'll be posting that. And if you have any other questions, you can send them along to us, and we'll try to pass them along to the team and facilitate answers. But thanks again to everyone for participating, and for all of you at home who are tuning in. I hope you all have a great rest of your day.
Thank you. Thank you.
Thanks for having us.
Thanks for having us.
Take care.